Okay, so before we start our lesson, we are going to be doing our bow work. So if you're absent today or you were absent before, make sure that you update your table of contents. This is very similar to the bow work that we did last class period, just simplifying exponents. Again, we're dealing with an expression. What's the difference between an expression and an equation? An equation has an equal sign. This doesn't have an equal sign, so we're dealing with an expression. It says write your answer using only positive exponents. So we're going to take care of the parentheses first, starting from left and moving to the right. So what is the first thing that you did? You could start this a couple of different ways. Yes?
You move in the first parentheses, you can move the b -4 down.
Yep. Yeah. So we can move the -4 down. What's a to the 0th power?
1.
1. Right. So I'm going to have 2 divided by b cubed times b to the 4th, all raised to the 4th power. And then, what do I do next? Yes?
You can combine the b and move the b.
Yeah, yes. Combine the b cubed and combine the b to the 4th, and what do I get? 2 divided by b to the what?
B to the 7.
7. Okay.
Times 4.
Now, we want to be very careful. We're not distributing, right? Distributing means we're multiplying everything by 4. Are we distributing a 4? No, what are we doing? We're raising everything to the 4th power. Okay, that's the difference. So you want to make sure that, words are important. They do mean something. They do matter. So when we take 2 to the 4th, what do we get?
2 to the 4th.
Which is?
Oh.
16. 64, that's a bit much. Okay. What's b to the 7 raised to the 4th power? b to the 28. Right. Paul isn't even here and he's answering questions. Okay, great.
Not right.
So, what do we do with the next set of parentheses? What do we do first? Yes.
Bring b to the -2 down and a to the -4.
Yep. We switch places with the b to the -2nd and a to the -4th. So, in other words, we end up with a cubed a to the 4th divided by 3b squared b to the 4th. And all that's raised to the 3rd, or all that's cubed. So before I take it cubed, what do I do? Yeah, add b powers with the a's and the b's. Why can I add them again? They have the same, starts with the b. Yes, base. Why is it b to the 4th power? Because I'm looking at this b to the 4th power on the bottom. Well, b to the 4th and b squared make b to the 6th. So I switched b squared to the denominator to make it positive right down here. And then this b to the 4th stays in my denominator because it's already positive. Oh, okay. Well, as long as I'm still doing the operations correctly, okay? So here in this case, I get a to the 7th divided by 3b to the 6th cubed, which would be what? A to the 21st. A to the 21st divided by what? 27 b to the 18th. So 27 b to the 18th. All right. Now I'm not done. What's the last thing I have to do? I have to multiply them. So when I multiply the 16 over b to the 28th power and the a to the 21st over 27 b to the 18th, what do I get in my numerator? 16 what? A to the 21st divided by 27 47b to the, I'm adding I'm adding the 28 and the 18, which would be what? 46. B to the 46. So this is my final answer. Again, if I could reduce a fraction, I would, but I can't here. Do you have any questions about any of those steps that I did? Yes. Yeah, because once I simplify this parenthesis and this parenthesis, because I want to do order of operations correctly, my parentheses first, then I can take the product. Yeah? Okay, great. All right. Okay, so continuing with our discussion of exponents, we're going to take a look at exponential functions. And more specifically, we're going to look at the graphs that they form. So we're going to look at characteristics including transformations, meaning that we're going to look at stretches and compressions or shrinks. And we're going to graph them. So the first thing we have to do is understand what an exponential function is. First of all, it's nonlinear, which means what? Not a straight line, it's a smooth curve. Okay, so it's a nonlinear function of the form y equals a b to the x. The a and the b serve very specific purposes for our exponential function. But first, before we go into that specifically, we know that a cannot equal 0. Why? What happens when a equals 0? It's just y equals 0, right? Which is what? What does that look like graphically? Yeah, it's a straight line, it's a horizontal line, right? That goes through the x-axis. B cannot equal 1. Why can B not equal 1? What's 1 to any power?
1.
Yeah, 1, right? So again, we'll get a constant. And B has to be greater than 0. So B has to be greater than 0. Again, we can't take 0 to the 0th power. And as the independent variable x changes by a constant amount, the dependent variable y is multiplied by a constant factor, which means consecutive y values form a constant ratio. That's a lot. So first of all, we have to understand that x and y will be increasing or decreasing by the same amount, but the y values in our y coordinates will be multiplied by a constant ratio. What's constant mean? The same thing. Ratio is just a fancy word of saying division, right? So it could be 4 over 1, or 1/2, or -1/3. As long as they're all being multiplied by that constant ratio, then we have an exponential function. Now the direction of our exponential function, whether it goes up from left to right, or up from right to left, or down from left to right, or down from right to left, really depends on our a. Okay, so we'll talk about that more specifically. First of all, we're going to determine whether or not the charts that we're given represent exponential functions. So you have to ask yourself when you're doing this, how is my x changing from one point to the other? Is it just increasing or decreasing by a certain amount, or is it being multiplied by a constant ratio? This is what? For a, the x values. You are adding what each time? 1. So 1 each time. So that's increasing by a constant amount. Okay, that still doesn't tell me if it's exponential or linear until I look at the y values. How are the y values changing? Yeah, they're going up by 2 each time. Not being multiplied by 2, they're going up by 2. So based on our definition of exponential functions, does this fit the definition of an exponential function? No. What kind of function is this? Linear. Linear. It will form a line. Okay. Does that make sense? Now the second one, how are my x's changing from point to point? Going up by 1. How are my y's changing? They're doubling, right? So I'm multiplying by 2, so what's my constant ratio? 2, right? 2 over 1 or 2. Okay, so this is exponential. And it's exponential again because you are multiplying by a constant value. Do you have any questions about that? Before we move on, remind me again, what is a parent function? or mother function. Remember that? What is our parent slash mother function? What does that mean when I say this is our parent function? Do I have any transformations? Yes or no? No. So our parent function is not being shifted horizontally, left or right. It's not moving vertically up or down. It's not stretching. It's not compressing or shrinking. So it's not reflecting. So what was our parent function for absolute value equations? Do you remember? F of x equals the absolute value of x. Now our parent function for an exponential is just going to be whatever our b to the x is. So if I had y equals 1/2 times 4 to the x, what's my parent function? Four to the x, okay? This 1/2 is going to be a compression. It's going to compress my parent function, which my parent function is 4 to the x. If I had y equals -2/3, 1/3 to the x, what's my parent function? 1/3 to the x. The -2/3, what does the 2/3 do? What do you think? Is it going to compress it or is it going to stretch it? Compress it. What's the negative going to do? It's going to reflect it. Right. It's going to reflect it. Okay. Do you have any questions? All right. All right, so this says evaluate each function for the given value of x. This is important because it's going to lead us into graphing. Because when we graph, we're going to use a t-chart, so we're going to have to evaluate for different values of x. So this says evaluate our function, y equals -2 times 5 to the x, for the value x equals 3. And then b says evaluate the function 3 times 0.5 raised to the x, and for the given value of x equals -2. Notice the parentheses. Okay, so for the first one, we're just simply going to plug in 3, and we're going to remember our order of operations. If you mess up your order of operations, then you'll get the problem wrong. It's very important, if you're putting something like this in your calculator, that you are very, very meticulous. Meticulous means just watch the details, okay? So, in this case, if you're plugging this in your calculator, you want to make sure that you type in your calculator 5 to the 3rd first, or in your calculator that you input 2 parentheses, so that your calculator knows to take 5 to the 3rd and then multiply it by -2. Okay? Otherwise, you will mess up. So 5 to the 3rd is what? Yes. Yeah, your calculator doesn't know order of operations. So if you just plug it in straight like this, it'll take 2 times 5 and then raise it to the 3rd. So you have to either do this first, 5 to the 3rd, then multiply that by -2, or you have to type it in like this. That's the second part. You don't have to necessarily use your calculator for one single step, but I'm just saying if you do, you want to be very careful. So what is 5 to the 3rd? And then times -2. -250. Yeah. -250. Nice try. Okay. Second one, same thing. Do not forget your rules of exponents. Okay, so y equals 3 times 0.5 to the x, and our x in this case is -2. What should I do in order to evaluate this function? Okay, exponent. How will I get rid of that -2, make that a positive 2? Yeah, bring it to the bottom. Okay. So this becomes y equals 3 times 1 over 0.5 squared. Again, if you're plugging this in your calculator, you want to take 1 divided by 0.5 and square it, or 1 divided by 0.5 times 0.5 times 3, and then you'll get your answer. So really what I'm doing is, that's going to be 3, and when I square that 1 divided by 0.5, I get 1 divided by 0.25. which will get me 12. So don't forget all your rules of exponents here. Do you have questions on that? No? Okay, great. Okay, so if you're following along on video, make sure that you do pause this and give it a try. My question for you guys is, looking at number 3, what is your parent function? 9 to the x. What is your parent function for number 4?
2 to the x.
2 to the x. Great. Okay, so here are the answers for that. Sorry, it's a little fuzzy. I didn't zoom in enough when I copied it, so it looks a little 8-bit. Exponential, linear, and then number 3, it had to evaluate it for 3 different constant values. 2 over 81, 2, and 6 are your outputs. And then 4, 0.375, 1.5, and about 2.12. Okay. Alright, so this is a key component for our lesson today. This is part 1, so if you're following along, check out part 2 after this. Graphing exponential functions. So the first thing that we notice is we're not dealing with lines, instead we're dealing with smooth curves. The graph of the function y equals a b to the x is a vertical stretch or shrink by a factor of the absolute value of a of the graph of the parent function y equals b to the x. So why do you suppose that we're only looking at the absolute value of a to determine the stretch or the shrink of our graph? Is a negative in front of that constant value, does that stretch or shrink our graph at all? What does it do? It reflects it. Right, so if I have something like, for example, y equals negative 2, the 2 times 2/3 the x, what transformations are happening? Am I reflecting? I'm reflecting because of what? The negative. Am I stretching or compressing? Stretching. I'm stretching by a factor of what? 2. Right. So let's continue on here. It says when a is less than 0, so here we have a less than 0, which we do. The graph is also reflecting the x-axis. This last sentence is very important. It says the y-intercept of the graph of y equals a b to the x is a. So without even graphing this or using a t-chart, you should know your y-intercept right away. What's a y-intercept? The point that crosses what axis?
The y.
The y-axis. So what is our y-intercept here? Zero what? Negative 2. That a value tells you automatically what your y-intercept is, that point that will cross the y-axis. Do you have questions before we talk about this even more? Okay, now, as far as the b value, so we've just been looking at what's in front of the number, what's in front of that constant, the 2/3. Now we're going to take a look and see how that 2/3 affects our graph. So, let's analyze that part of it. Let me erase this. It says when b is greater than 1. So, if we have, for example, let's say 4 to the x, okay, that b value is greater than 1. What's my a value, by the way? My a value is 1, right? There's an implied 1 there, because I'm multiplying by 1. Okay, so if my b value is greater than 1, this is what's going to happen to your graph. It's going to move from left to right coming up. So, left to right coming up. So in other words, if I take my finger and I move across the graph from left to right, I'm moving up. The only difference with the reflection is you're moving from left to right, what? going down. So it's that whenever you have a reflection. And that's when I'm dealing with the b value greater than 1. By the way, what's my y-intercept for this one? My y-intercept can be found by looking at my a value. We said my a value is 1, so what's my y-intercept? 0, 1. A lot of information, and I know it's new, and it's kind of like, I don't remember. A lot of information from the exponential function. What does my a tell me? What does my b tell me? Okay, now looking at the b value again, let's say instead of a 4, we have a 1/4. So in green here, let's say I have a 1/4 to the x. How's that going to change it? Well, it's going to move from right to left now, instead of from left to right. So from right to left, coming up, or from right to left, coming down, if it's reflected. So in other words, if I take my finger here and I move across the graph, coming up, I'm moving from the right to the left. Okay. Do you have any questions about that? Let's look at a few cases before I move on. Okay. This first one, am I moving from the left to the right or from the right to the left? Right to left, okay? So, if I go back to this chart here, I have a b value that's in between 0 and 1, so I'm going to be moving from right to left coming up. So my graph, I already know I have a kind of a rough idea of what it's going to look like. All right. What transformations are taking place here? It's being reflected. Okay, what else? It's being stretched by a factor of what? Nope. By a factor of 2. Stretched by a factor of 2. Okay, looking at this next one, am I moving from the right to the left or from the left to the right? No. Left to right coming up because of what? Because is it the 1/4 of the 3 that's making it move from left to right? It's because of the 3, right? Yeah? Okay, and then what's the, and so what transformations are taking place? Being compressed by a factor of? This is going to take some practice. Okay, I just kind of want to let you know what to expect. You're not going to get it probably the first couple of times that we do it. You just have to take some time with this material. Okay. Going back here, do you have any questions? Okay. And also remember, this actually isn't an accurate stretch because it's being reflected, or a sketch. So, let's do this last one, and then we'll be done. So we're going to graph this. I'm going to go by 1s here and by 4s on my y-axis. First thing I want to know, what is my parent function? 2 to the x. What's happening to them? How's it being transformed? Yes. Stretched by a factor of? Yes. What is my y-intercept? 0, 4, right? Okay, so I already know without making a t-chart that I have a point right here. I'm going by force. Good so far? The next thing we're going to do is just use the t-chart. Remember, when in doubt, t-chart it out. So we're just going to make the t-chart here. X, y, -2, -1, 0, 1, and 2. Why do we use those values? We don't have to, but it gives us an idea of what's happening at the origin, and a couple points to the left of the origin, and a couple points to the right of the origin. So I'm going to do exactly what I did in the very beginning slides, where I have to evaluate for each of those individual values. So I'm going to plug in 4 times, or I'm going to evaluate the function 4 times 2 to the x, but I'm going to replace x with -2 and evaluate that. So what's 4? So what am I multiplying 4 by? When I get rid of that -2, make it positive. 4 times 1 over what? 1 over 2 squared, which would be 1 over what? 4. So I get 1. Okay, and then we keep doing that for the rest of the point values. 1, 2, 4, 8, 16, and all I do is plot them. Okay, so -2, 1. Calculating by 4s, 2 is about here, 1 is about here. -1, 2. 0, 4, which I've already plotted. 1, 8. So 4, 8. And then 2, 16. Which is right here, and then I just make that smooth curve. What do you think my domain is? All reals. Why would it be all reals?
So we can keep going on.
Yeah, it's going forever to the left, forever to the right. I have, no matter what my x value is, I have some point on that graph, right? So it's all real. What's your range? Yeah, y is greater than 0. Does your graph ever actually touch the x-axis? No, it's what we call, it gets arbitrarily close. It's a fancy way of saying it gets closer and closer and closer and closer to 0, but it never actually touches it. So it's going to be y is greater than 0. So it's anything above 0. Yes? Well, if you see something raised to a variable, then you know it's an exponential function. Yeah. If you're looking at the y value flip, if you have an idea of what. Okay, that's what we're going to do for now. So if you're watching this video, we don't have any homework. Look at the second video for the homework. Tomorrow will be a work day, so you'll have the majority of the time after the lesson to work on the homework.